So what we're going to be talking about today is all about connecting those dots between why we always say you should turn your lights off when you're not using them and how that links to climate change. So we're going to start off by talking about electricity. And loads of us all over the world, we rely on electricity for so many things. Whatever you're watching us on right now, your computer screen, your phone screen, that requires electricity. The lights in the room, maybe when you're preparing your food, all of that requires electricity. And a lot of our electricity comes from a fossil fuel power station. So here I've got a little model that I'm going to talk through, and it's all about where our electricity comes from. Now, a fossil fuel is basically a fuel that we use. It includes coal, oil, and natural gas, and those fuels take millions of years to develop. So they come from dead animals and plants that died a really long time ago, and then because of lots of high pressures and high temperatures, it converted those dead animals and plants into those fossil fuels, which we then dig up and we use them in power stations, like I'm going to show you this model in a minute, to generate electricity. So on our little model, I'm going to show you how this works, and I'm going to explain how we generate electricity in real life. So in this little container, I have got an alcohol. It's called isopropanol, and this is representing our fossil fuel. So in real life, we would be burning a fossil fuel like coal, oil, or natural gas. So I'm going to light this, and it works a little bit like a candle. So there's a wick inside here that draws that alcohol up, and then that is burning. And I'm just going to pop this on here, which is our model power station. And in a real power station, what would happen is when we burn this fuel, it would be underneath a really big container of water. It would heat up that water, causing it to turn from a liquid into a gas, into steam. That steam would then go through the power station, and it would go to what we call a turbine. And a turbine is just basically a fancy word for a big fan. And that turbine is connected to an electricity generator. And the electrical generator is like a really big magnet with wires coiled around it. And then as that turns, it generates the electricity. Now, our model here doesn't have all of those parts, but it works in a very similar way. So now I've given it a little bit of time to get warmed up. I can get it going. There we go. And I think it just needs a little bit more time. So we'll just give it a couple of seconds longer. We just need to get this area to heat up a little bit more. But when we're burning our fuel is undergoing a special chemical reaction. Now, I wonder if anyone at home or anyone at school can think of what the scientific word is when we burn a fuel. The word begins with a C. See if you can think of it. If you're in the classroom, maybe pop your hand up and tell your teacher, and see if you can think of that scientific word for burning a fuel. If you said combustion, then really well done. It is combustion. So there we go. It's getting going now. So we are having combustion take place with our fuel. And that's what happens to those fossil fuels in a real power station. And when a fuel undergoes combustion, it's reacting with a certain gas in the air. Now again, at home, at school, see if you can think of what gas that is. What gas in the air is our fuel reacting with when it is burning? If you said oxygen, then well done you. It is reacting with oxygen. And we have generated some electricity. Now, this electricity would go from our power stations along big cables, maybe overground or underground, to our homes and buildings. And when it gets to our homes and buildings, we can use that electricity for our power in our homes. So we might need some lights. Have a think and see if you can come up with some ideas of things in your homes or in your schools that you need lights for, or that you need electricity for to power the lights. Now, you might have said maybe a TV screen, or perhaps a computer screen. they all require light. So what I'm going to do is I'm going to connect, if it works, it's a little bit broken, it's a little bit fiddly, but I'm going to connect this light bulb to our circuit, and hopefully we will see some light. We get a little flicker there, I accidentally touched it a tiny bit. There we go. So with our power station, we've generated some electricity, and this has given us some light in our light bulb. Just like what happens when the electricity goes from a real power station to our homes to power our lights. Now, we don't just need electricity for light, we need it for other things instead, including sound. So at home or at school, see if you can think of some things in your homes or in your schools that we use electricity for to produce sound. Have a little think, see what ideas you can come up with. And you might have thought of maybe things like a telephone, or maybe a microwave when it beeps when it's ready, or again a TV that produces sound as well. So I'm going to connect up this buzzer. And hopefully on your end, you can also hear this really annoying noise coming from this buzzer. And again, this is being powered by our power station. Now, I'm going to blow this out and have a think about what's going to happen now. What's going to happen if our fuel is no longer burning? We can see our power station is starting to slow down. We're generating less electricity. And the sound is starting to go off. And if you think about in real life, if something happens to our power station or something happens taking our electricity from our power station to our homes and buildings, that's what can happen. We can have a power cut, so we can have problems there. Now, this is a fossil fuel power station. So remember, those fossil fuels are coal, oil, and natural gas. Now, there are other ways we can generate electricity. We can use renewable forms of energy instead, and we'll think a little bit more about that at the end of our session. Now, when we have things like cars or planes or buses, they also require power, but they don't need a little flame like this. In fact, they need a really big explosion. Okay, so in a car, there are actually hundreds of mini explosions happening every second to make your car move. And that's what we're going to look at next. So I'm going to move over there and we're going to have a go at doing a little explosion. Now, in here, I have got some of that alcohol again. It's called isopropanol. And I'm going to shake it up in this bottle. And what I'm doing is I'm trying to turn it into a vapour, into a gas. And then in a minute, I'm going to light it. And hopefully, we will get a big explosion. Now, in the bottle, there isn't just the alcohol. There's something else in the bottle as well. Can anyone think at home or at school, what else is inside the bottle? What am I mixing the alcohol with? Now, if you said it is air, or if you said it is oxygen, then fantastic job, it is indeed. I'm trying to mix my fuel with the oxygen in the air, just like we did a minute ago with our model power station. And then, hopefully, if I've done this enough, we will get a little explosion. Now, I don't want that excess isopropanol, so I'm going to pour the rest of that out. I just want the vapour. I don't want any of that liquid left over. So I'm just going to make sure I have poured as much of that out as possible. And then I'm just going to pop the lid on just to trap any of that vapour so it doesn't escape. And then I don't want to be too close when I light our vapour. So I've got a very scientific piece of equipment here. I've got a meter stick with a splint attached to the end of it. And what I'm going to do is I'm going to light the splint, then I'm going to take the lid off the bottle, and hopefully we will get an explosion. And the reason this is called a whoosh bottle is because it makes a whoosh noise as it catches a light. So keep your fingers crossed and we'll see if it works. It did! It didn't make that much of a noise, but it did work really, really well. In fact, it actually took quite a long time for that vapour to catch a light. And that shows you how much energy, how much chemical energy is stored in our fuels that we use, like this alcohol. Okay? Now, I'm going to move over to this area now, and I'm going to explain what I've got these coloured sections here all about. Now, a couple of weeks ago, my friend Becky, who also works here at the aquarium, she did a little session about ocean pH. And if you didn't watch that, then do not worry, because I'll fill you in and remind you of what you might have missed. Now, the pH scale, shown by these bright colours on the side here, they are what tell you how acidic or how alkaline a liquid is. Now, the scale goes from 1 or from 0 all the way up to 14. And you can add a liquid called universal indicator to other liquids to tell you what the pH is. Now, here I've got some water from our taps, and when I added universal indicator to it, it went green. And that tells us it is in the middle on our pH scale. It is about a pH 7, and that tells us that it's neutral. However, when Becky did the experiment a few weeks ago, she had a little competition where she had different animals and different people blowing carbon dioxide out of their mouths into the water, just like what is happening in our oceans. So when we burn a fuel, in our power station, or when we burn a fuel in our cars, like I showed you a minute ago with that whoosh bottle explosion, a certain gas, carbon dioxide, is being released. And lots of that gas goes out into our atmosphere, that blanket of gases around the Earth. However, about 50% of it actually goes into our oceans. And Becky showed us how when that carbon dioxide goes into our oceans, so when we blow into this water, it actually turns our oceans more acidic. So when we blow from our mouths out into the water, it made the water turn a more orangey red colour because it was turning more acidic. And that is what is happening in our oceans. And this can be a problem for lots of animals. So we're just going to move along to this bit. So here I have got quite a lot of artefacts of animals that have what we call a calcium carbonate skeleton, or exoskeleton. So here we've got a lobster, we've got some animals that live in shells, like this beautiful nautilus shell, and we have got some beautiful coral skeletons. And all of these are made of that calcium carbonate. And in a session I did a couple of weeks ago, I explained how when that carbon dioxide goes into the ocean, it can affect how strong these animals' skeletons are. Now, there's a little experiment that you could do at school or at home to represent what happens when our animals are living in an acidic ocean. Now, all you need is really simple, is a little film canister like this, and fill it with some white vinegar, half fill it with white vinegar. And then you want to take an Alka-Seltzer tablet like this, it's basically just a fizzy tablet, break one in half, and what you're going to do is very safely, is you are going to pop your tablet into the canister, put the lid back on, and then turn the canister upside down, pop it on a hard surface and move well away, and then you should get an explosion. And when we've done this before here at the aquarium, often the explosion actually hits the ceiling. It's so big. And when you look at the tablet afterwards, you can see that the tablet will have broken down. And that is representing what happens if our animals with calcium carbonate skeletons or shells are put into an acidic environment. It makes their skeletons or their shells really weak, and it causes them to break down slowly. Now, our oceans are not going to explode, just a disclaimer there, but this experiment is a really nice way that you can do at home or at school to kind of explore how the acidic environment can affect our wonderful animals. Now, our last bit of our session is talking about what we can do to help the ocean and reduce the effects of climate change. So Andrew's just going to move the camera very quickly whilst we get into our next position. Perfect. So in our session today, we have spoken about how we have our power stations, they have fossil fuels which they burn, and when we burn a fuel like coal, oil, or natural gas, it releases carbon dioxide into our atmosphere. That sometimes can go into our oceans and affect our wonderful animals that live there that have calcium carbonate shells or skeletons. Now, we mentioned earlier that there are actually nicer, much more friendly ways for the environment that we can generate electricity. So we call those renewable energy sources. They include things like solar panels or wind turbines or hydrothermal energy, and those are renewable energy sources. But there are many things that us as individuals can do as well to reduce our impact of climate change. And the first one is all about transport. Now, I doubt many of the viewers here have their own car, but I'm sure lots of you will ask your family or your guardians for lifts to your friends' houses. Now, we're not saying that you can never drive again, but what you could do is you could just try and walk a little bit more. If your friend's house is nice and close, then rather than going in the car, you could walk, or you could get the bus, or you could cycle instead. And that will reduce how much carbon dioxide is being emitted into our atmosphere. Now, the second thing that you can do relates to what we're buying. Now, lots of things we buy have plastic packaging, and I'm joined by my wonderful friend Andrew, who has got some plastic attire on, looking very, very fashionable. He's got a lovely wig on as well. Now, plastic comes from oil, and producing plastic that happens in factories also releases lots of carbon dioxide as well. So our second thing we can do is just to buy less plastic packaging, or try and reuse or recycle plastics if we've got them. Now, the third thing we can do, again, is about what we buy, and Andrew is back with us. He's had an outfit change, and now he's got a wonderful marine-themed shirt on. Now, we all love to look fashionable, but often we buy too many clothes. And often what we're doing is we're buying clothes that are called fast fashion. And this is where we're buying clothes that are maybe made quite cheaply, and we're buying it too frequently. And the factories that produce these clothes, they are also emitting lots of carbon dioxide. So our next thing we can do is just to reduce how many clothes we buy, or to buy more sustainable brands. Now, the fourth thing we can do, I said at the start, a lot of us probably leave light switches on, and we were going to fill in those gaps as to why we shouldn't do that anymore. Now, Andrew's had another outfit change, and he's now got a high-vis jacket on. He is resembling a light switch. And loads of us, as I mentioned, we leave light switches on when we should just turn them off if we're not in the room, or TVs or Xboxes. We just need to turn them off so they're not wasting that electricity. So that's what I'm going to do, Andrew. I'm just going to pop this up, and I'm going to switch the light off. Okay? So super, super simple. Very, very nice. Thank you very much, Andrew. And the last thing that we can do is about what we're eating. Now, we are not saying that you can never eat animal or meat products ever again, but lots of animal produce releases lots of carbon dioxide or other greenhouse gases into our atmosphere. So Andrew, he's had his best outfit change yet. He's now in a hot dog costume because we are talking about eating meat. And eating meat, as I said, can release carbon dioxide into the atmosphere, or methane, which is a similar gas. So what we can do for our last way to reduce our carbon footprint is just to eat a little bit less meat and be a bit more mindful about what produce we are buying and eating. So thank you so much for joining us here today. We hope that you have enjoyed seeing our experiments and you've learned a few bits